Good morning. Thanks for staying. My name is Slavek Zaremba. I'm the Chief Technology Officer at SparkCognition for predictive maintenance. Very glad to be here. This is going to be a little bit different. This is not my slide. This is my slide. This will be about a man, a dog, and a pipe. So we just heard a great presentation, great discussions about how industry is moving towards autonomy. What I will not show you and I will not talk about is a demo of the product. We have our team in the back there. They will be more than happy. They love nothing better than to give you the demos and talk about our product, SparkPredict. So please stop by whenever you have a chance, and we'll be glad to show you. This is my one opportunity a year to share with you, with our clients, our partners, our friends, our current designs, what we're currently working on. This is your one shot a year, and it's not even Christmas. So this should be very exciting. I'm very excited about this. So as I mentioned, this is about how AI is helping move to the ultimate automation, the autonomy, right? This is what Paul Browning was talking about. So I will show you these exciting demonstrations, but before that, I'm going to run a little quiz for you, okay? So, very simple question. What is this? Okay, anybody? I can't hear you.
This is not a pipe.
Ah, okay, well, you should have said this is a pipe, okay? Why is this not a pipe? You speak French, or you know the... Okay. Ceci n'est pas un pipe, right? Why is this not a pipe? Why is this not a pipe? Can you smoke it? No, right? It's not a real pipe. What is it? It's a painting of a pipe, right? It's actually not even a painting of a pipe. It's a photograph of a painting of a pipe. Actually, not even that. It's a projection of a photograph of a painting of a pipe, right? This is a painting that was made in 1929 by a Belgian surrealist painter, Rene Magritte. And you may know him from other work that he made. He was very famous at the time. You've probably seen a businessman in a bowler hat with the green apple in front of his face. The same guy. So the guy went to the effort of painting a pipe, and then underneath he says, this is not a pipe, okay? But what is he talking about? This is a representation of a pipe, right? And representation is a very fundamental concept, not just in AI, but in civilization, okay? Representation is how you generalize and create knowledge, right? There's millions of pipes, right? And I can show you a pipe that you have never seen before. You will look at it, and you will immediately say, this is a pipe. Why? Because you have that in your memory. You have that representation of the pipe that's encoded in you, right? I'm going to run another experiment. What is this? It's a pen. You have never seen this specific pen. This is a fountain pen made by Crow, whatever. You have never seen this, yet you have no problem saying that this is a pen. Why? Because you understand the representation of what a pen is, right? So now you can see things that you have never seen before, and you can now communicate, you can make decisions about it. This is what allowed us to create civilization. This is as profound as that. Now, I'm not going to ask you what this is, because nobody's going to say it's a bearing, right? But this concept is now applied in industry, in everything that we do, right? What do computers do? Computers create generalizations. What AI does is it looks at data and then creates a representation of that data set. It generalizes this, and now I can apply the generalized concept, right, into a unit that has not even run before. We call it clusters. So we create a representation through clustering. We generalize that representation. Now we can apply it to a unit that has never run before. And now I can actually tell about the behavior that I'm really interested in, even though I have never seen it before. This is a very profound stuff. And this is what AI is now capable of doing today. So let's do some exciting things. Hopefully you get to see this. These are rather small images. But I'm going to run you now through the simulations of the product that we're currently building. What AI does at the beginning, and this is SparkPredict, it loads in thousands and thousands of data points. These data points are read, not just the time series and the values, but also because we understand language, we can tell descriptions of this data, metadata, the data about the data. And from that, we can now discover not only that this particular signal reads in degrees of Fahrenheit or Celsius, we can also say that it comes from a gas turbine or it comes from a generator. That allows us to discover assets that we are tapped into the data that it measures. So you can see now the SparkPredict is detecting gas turbines, generators, and so forth. It goes to the next level. It detects interrelationships among these objects. And now it can create a representation, not just of individual assets, a representation of a plant, right? It gets better than this. Now I'm doing the same thing, but not just loading time series data, but I am loading text, information about maintenance, about failures that I've seen over the past years on the equipment that I've looked at. And now what's happening, AI is reading through all this, it's identifying whether this is pertinent, to what assets this is pertinent, and now it indexes my data set, my representation, with that information. After that, I am ready now to build my representation, or as we build models, right? Or AI representation of the reality, of the real plant. So first, the data qualification and validation is done, and then we're running various types of models that are best to represent particular objects, particular reality. And at the end of the day, we have a model now that represents our plant, and we can execute this model and look for interesting or important or dangerous things that are of interest to us. I have a couple more things to show you here. And what we're doing here is we're running the model, and the model just detected new assets. So remember what I was showing you about representation. I've discovered new assets that were just built, added to the plant. I have no prior knowledge. There's nothing I can do without encoding the expert knowledge into rules. Well, no, because I just showed you, I can create a representation of assets that was similar to these ones that I just discovered. And based on that, I can now create models that will tell me about the health and the behavior of these new assets that I have never seen before, just like with this pen, right? Now I've built a representation that I can adapt to the new asset. And there's one more thing that I wanted to show you here, and this is another type of learning that we're doing is reality changes. That requires adaptation of your representation. Let's say that there was a maintenance that was performed on one of the assets. Something was changed, a part was replaced. As a result, the behavior changed. AI discovers that the change happened. It reads maintenance records and information, so now it can connect the dots and realize that this change that happened was a benign change that had to do due to maintenance. Now it maps back to what part of the model, of the representation of the plant, was affected, and now it can recalibrate itself. It reruns the models to now better represent the new reality that just has changed. Now, how often would it have to be done? Forever, right? This is continuous learning process. That's what machine learning is all about. Okay? I have a couple more minutes, so I'm going to wrap up, but just to make sure we have the power generation people here so they know this, even though the autonomy is an issue that's being worked on it's very exciting right now. What's happening is happening now in cars. Obviously, autopilots have been flying us for quite a while. In power generation, thanks to leaders like Paul Browning and Mitsubishi Hitachi Power Systems, this is happening right now. But this is a dream that's been going on for a very long time. And it's a very old joke in the power generation business that's over 40 years old now. So 40 years ago, experts in power generation met, and they were trying to predict the future of the power generation, what the power plant of the future is going to look like. And they all agreed that they really don't know. But they know one thing. They know how that power plant of the future will be staffed. And it will be staffed with a man and a dog. Why the dog? The dog is supposed to bark at a man anytime he tries to touch anything. So why do you need a man? To feed the dog. All right. This is happening. This is the reality today, and it's happening thanks to the advances of AI. The way AI now can take information from the data, create representations that now can then be used for decision-making process and communication. So if you would like to hear more about this, we're here at the end on the right-hand side. We'll be very happy to talk to you. Thank you very much for your attention, and hope you have a great session. Thank you.